Yeah, you can. I've started the recording. You can share your screen and then we can start the session.
Sure.
I will let you. And I think most of you have already attended Sri Chayan's session for the workshop one. I think you know like what he does. I will let him to introduce himself much more better.
Yes. Okay, I'll start with my simple introduction. I'm Srijain Rajendran, working in ThoughtWorks related to data science scope of view. And currently, I majorly work on day-to-day. My day-to-day work is work related Gen AI things and train new models on Gen AI related things. Computer vision, I have worked uh, quite before. Uh, Today, I will try to explain you how the hand symbol recognition works. I have a demo and I have a code for you. I'll show you the demo and give you a simple introduction on computer vision, and I will just show the code and code walkthrough we can do. Then if you have any queries, we can take. Let me share the screen and show you the demo. What? Mm, One second. One second. I think there is a small issue in sharing the screen. One second.
Were you able to know?
One second.
Okay.
Okay. Sure. Are you all able to see the screen? My VS Code, right?
I'm actually able to see a black screen.
Okay.
Actually, we are able to see your meet.
Uh, Meet screen, but now you can see the calendar.
No, now, still it's in the browser, like
Okay.
the call screen. Yeah.
I've just given the entire screen menu, but why I can't share?
Yeah, now I'm able to see it.
VS Code. Can you are able to see the VS Code, right?
Yes, yes, now we are able to see it.
Super. Super. One second. I will just start with the demo one. Py. Okay, now I think now I'm just starting the app.py, the main file of our code. I think now you can see this. I think now you can see my camera screen, right?
Yes.
Yes, super. This is exactly what is the demo I have kept here. Here we could be able to recognize the hands over here, and we can also see the names of the hand gesture over here. Maybe like n number of hands we can able to add. We can just have the open hands, close hands, like we can also have some pointers over here. The main thing is we can add custom names and custom details for our each and every gesture. We are going to see how it happens. Like I'm seeing welcome to the talk. For this symbol, what the four hands open and the thumb finger closed, I have set it like welcome to the talk. This is a customly trained and kept like this. For like this we can, for n number of symbols we can keep n number of hands over here. That is the main concept and the main overview of this talk. Maybe I have closed it now. Now can you see these slideshows, right?
Yes.
Okay. uh, let's start. Basically the demo what we saw now, right, that happens because of a computer vision. Maybe I will give a very basic example of, I mean, basic walkthrough what is computer vision, and then we will go through the code, and after that let's see. First of all, from the starting, what is computer vision, right? Computer vision is nothing but a science or technology where like we see something and understand like that computer sees something. We are giving vision to the computer using cameras, and our brain process it and says what is this, and like that the computer process the camera's feed input, and makes the computer to understand what is it seeing actually. I mean, computer vision is used in n number of areas. Lots of areas are nowadays adopting computer vision. Now currently in AI field, Gen AI is in a super boom last 2 years. But before that, or even though a silent very huge gap is needed for computer vision areas, because some particular task can be done only using computer vision, even though some Gen AI multimodal came into picture and able to create videos or understand images using Gen AI also. It is a very very costly process. Instead of that, if we are trying to develop a computer vision model, right, that will be a 100x cheaper, and our accuracy will be somewhat higher than the LLMs, because and this is trained on the specific data what we want to achieve. But no, LLMs are not like that. LLMs are fully, I mean, multimodal LLMs are not like that, which is trained on massive number of data. So that is somewhat costlier. But nowadays it is taking up the computer vision. Transformer based computer vision is also nowadays getting boomed. This computer vision can be used in like person detection in night, understanding what's in the image, and even crash detection, or passing an X-ray scan or MRI scan to a computer vision and detecting some diseases is present or not. Everything is can be used using computer vision. Basically, as I already said, like image processing, how a human and the computer process the image. Basically, human sees through eyes, passes the information to the brain, and brain understand what is the human seeing and gives a result. But computer is doing the same thing using here it is mentioned like sensing object. Maybe it is not only computer vision, like can be achieved only using a camera. It can also be something like 3D lidar, because most of the autonomous vehicle only not rely on cameras. It relies on lidar or radar data. So it is said as sensing objects. After the object is sensed using a device, it will be passed to a computer or a processing device, which will calculate. It does nothing but a mathematical matrix calculation. After that, it will be given as an output of in a probabilistic percentage. How much I mean, it is how much percentage will the object be. uh, it is same like LLMs gives words as a probabilistic output, but this computer vision thing mainly focuses on the objects and the classes which we already specified. Now these tomato, apple, everything will be like already specified by humans as classes, so it will be easy for it to understand this object which is showing, I mean, which has been seen in the camera should be within the list of objects. That is the main thing. Okay, when it comes to history of computer vision, right, it started late before 1950s, or that period itself is started. But some milestones are I have just listed out here. Like 63 was like image were able to sense tridimensionality of a scene. Means like image will be consisting of RGB colors. There are, then that means each pixel will be having three matrix value. Like that, there will be, nowadays our phone cameras are able to take up to 4K images or 4K videos. That means that is 4000 dimensional of pixels. So each pixel will be having three values to represent the RGB. That started in 1963 over. And 1974, their milestone was like achieving the OCR part of some text, which is printed text, which will be able to identify the characters in the image. And 1980 was something very important period. Like Kuniho Fukuma. She's a Japanese researcher who mainly introduced the concepts of hierarchical multi-layer neural network. Because those days was like there will be input layer and there will be output layer, and hidden layer will be inside there. But she introduced the hierarchical methods of hidden layers over there, so that the model can understand the complexity of the object which is shown. Let's try to imagine, like if you are trying to detect a dog. Let's say, let's trying for a detection of dog, then it must be able to understand different types of dogs, and it must not identify cat as a dog. So there are more complexity getting involved when it goes through a large number of data set. So only multi-layered neural network will be helpful for identifying each and every feature of the dog. Then comes the 2000 period. Is like face recognition application was boomed, so that only we started getting in phones and digital cameras, we started getting a face detection thing. And after that only face detection part and image processing all came. But when did it came to every developers or every person from their laptop itself, they started running, right? That came after the 2010 and 2014, where ImageNet data was available, made available for everyone. It contains large number of variety of classes. Like uh, uh, the class may contain a dog, a chair, a person detection. Everything will be available in the data set, so that people uh, were very easy to get the data from this. After getting Coco dataset as free available open source, right? It was open sourced by Microsoft. That made a huge difference, because people started building different types of model in different level of different multi-layered models, or different architectures were built around this data set, so that it became more standard and more available for all the people. This is what a computer versus a human sees. Human sees a picture like a human is standing and taking a photo through a camera, right? But computer sees everything in pixels. Here, why we didn't specify the three values in each every pixel? Because it is RGB. I mean, it is not an RGB image; it's a grayscale image. So we can specify the image value using a single vector. I mean, single vector, maybe like single value. So that this is what a uh, computer sees when an image is passed into it. So it calculates this. Consider this as a matrix, and this matrix are getting processed through the neural networks, and it gets learned. Okay, this is a person. Like that, only computer vision itself started evolving. The major use cases in computer vision is like when it comes to safety, as I already said, or when it comes to healthcare sector, like passing in the image, an X-ray copy or MRI copy. When it comes to also safety reasons, right? So most of the CCTV camera nowadays integrating the safety techniques using the computer vision things. And when it comes to comfort, now we can see OpenAI and Boston Robotics are started releasing their own custom robots for helping tasks like in household activities or in workplace itself. That all involves lots of computer vision over there. We can also, we can also use it in fun areas, or also all our Google Photos has a not exactly a computer vision, image processing technique, which able to detect what is the image you have taken. You can also now they have released a feature, you can search about an image, and the image could give you what if you store image in the Google Photos, right? You can search by its name, just uh, show me some credit cards which I have taken a photo, it could able to list wherever it is. So these all involves the computer vision part over there. When it comes to major classification of computer vision, right? uh, those are we can classify an image which comes under a classification part, or a detection image, detect a image, like we can that is called typically an object detection in an image or a video. Then comes the segmentation part, then tracking also comes, and then the post comes. uh, I think by seeing this image itself you can understand most of the thing, but if we go deep into it, right? Classification is none other than classifying a particular image. If we pass an input to an image, it will classify it. For an example, it is a dog or cat. That is the main. It may be a multi-class classification or a binary classification, but these all kind of things will come under a classification part. The use cases are when we are processing a retail store, right? Maybe in future, or some places we have auto billing concepts, so that we can easily classify the product name. And when it comes to healthcare sector also, we can use this classification part. Then comes the detection. Detection, I think most of the people will have seen this detection part, which is detecting a person or a car or a traffic light, maybe anything in an image. If we want to train and detect that part, that comes under detection, which the use cases are security purpose, or nowadays AR VR started doing this. And industrial automation needs a lot of detection process, like if in a conveyor belt, is the product passing in a good, is the product didn't get any damage or like that. If you want to detect, that is all possible using this detection part. Then comes the segmentation. Segmentation mainly focuses on detection and segmentation are more similar, but if we want to identify the objects width and height very accurately, right, then comes the segmentation part. This is mainly used in autonomous vehicles and also in medical image processing, so that it could easily identify the object's height and width very accurately. Maybe this is mostly done in camera itself. Still more in-depth analysis of the objects can be done using lidar or radar data. I'm saying this for autonomous vehicle processes. Then comes the tracking process. This is also more related to the object detection part, because first of all we need to identify the object what we wanted to track. Then only we can track the when the person move. If we are trying to detect a person, right? Track a person, then first we need to detect the person, then only each and every time the a person moves, the tracking will also follow the person. This can be done in traffic monitoring system, or sports analytics. Both the things can be used over here. Then last step comes the post estimation or post deduction. This is nothing but is there any a certain defined task can be done using post estimation, detecting a person. Now we are currently going to do about the hand pose, so that it will able to identify the fingers and its joints more easily. This use case can be done in fitness areas, or human computer interaction, because we can maybe we will see in the next slide, human computer interaction is without even using any interaction like a mouse or keyboard. We can interact with the computer. That is the main area. When it comes to fitness, when we take a use case of yoga monitoring, if we take a yoga monitoring, then is the person doing the things in the correct angle or a correct posture is the person doing, like that we can identify over here. uh, this is what we are going to do today, like how do computer understand. Basically we will pass the computer, I mean we will pass the camera feed image to the model, which will easily split out the RGB colors and able to process it first. Then that process will convert the we will able to point out what are all points available in our hand. Then after that, that points will be passed to another model, which will be able to identify what is the hand coming to say us. Is there any meaning to the is there any meaning for the hand symbol, like that we are going to identify. This is called gesture recognition. Like already said, using the posture thing, right? I mean posture estimation or posture detection, everything leads us to gesture thing, which allows us to I mean say something using any posture pose. Using a pose, we are making a gesture and communicating to users. This is the main example, like which I already said, right? Human computer interaction. This is also an example. I think most of nowadays latest TVs have this feature, like there will be a camera above the TV, so that if we start moving our hands, it could able to identify, it acts as a mouse to the TV. This is what I had in the code overview. Let me share and explain about the I mean coding thing. This is the overview of computer vision. Yes. I think as of now, do you have any doubts? If you have any doubts, please feel free to share in chat area. I think no, I think you can see the VS Code screen. Basically, first of all, we are trying to run an app.py file, which this is I mean this takes care of this will be taking care of detect when we pass and image, I mean computer, I mean camera feed, right? It will be able to detect the hand very accurately, even in if it is in a large distance or anything, it will be able to identify the hands. That is the main part of this code. First part comes like what are all actually I'm explaining this code part so that you could able to modify this code more easily for your use case or your thought process very easily. uh, these are all these are very simple structured code, so that if you want to modify this use case, right, into want to fit into your application, so this can be done more easily. uh, First of all, we are setting up the devices, like what are all the devices needed. I mean devices needed means like are you going to run this whole process in your CPU or GPU? If you don't set anything, it will automatically choose CPU method. Then what is the height and width of the uh, screen to capture? Then use static image mode is something like are you going to send the camera feed which is in your laptop or anything else? Then minimum detection confidence is already we said, right? If this point is any point in your hand is getting detected, what is the minimum confidence? If it is above 80% only, you want to show the point, you can set the minimum confidence. Else now it is by default it is 0.7, which is 70%. And minimum tracking confidence is 50%. As I already showed in the demo, right? A pointer is over, I mean by figuring out the pointer in the cameras. Maybe we can see the demo meanwhile also. Then comes the main function. Main function has uh, first of all, it gets all the argument data over here. Then it loads the classifier over here. Like what are all the classifier means? Like it is like to be saying these are all classes which I have inserted, I mean trained to the model, so that it could able to detect open, close, pointer, okay, peace symbol, and welcome to the talk. These are all the things which I have trained to the model, because it loads that to show the name in the camera feed. Okay, right? Then it uses OpenCV to get the camera feed from the laptop and pass it to the model. First of all, it will try to detect the I mean, try to draw a rectangle around our hands. That is done by the cal bounding box rectangle class. I mean function, which will be getting the input of the highest point and the lowest point of our hands. Like if we are seeing this, right, one second. If we see this, right, we can see if we are showing the hands, this is the highest point where the rectangle should start, and this is the lowest point, and these 2 points are the width of our hand, so that we can easily draw a box over here. It gets the input as input from the model, and finally it will draw a bounding box using the xy will be the up and top and bottom, and this will be the left and right area to cover by the rectangle. That is the first step happening here. Then we need to create the landmark list. Landmark list is nothing but the point we are exactly seeing here. These each and every point over here in the hand, right? This is called a landmark for this code. Like each and every point will have a xy coordinate where it should point. That is exactly happening, and it is plotting over here. To see that, right, I'll show you one example. If I just uncomment this print statement of landmark point, right? If I just start running this, yes, I think now the camera feed started running, but we can't see any landmark points over here. But if I just take the hand over here, right, we can see the landmark points just popping inside here. We can see that each and every have an xy coordinate, so that this is the first point's xy coordinate, this is the second point's xy coordinate. Using these points only, it is able to easily point in the camera feed itself. We can see it over here, right? It is easily able to draw using this point, the xy coordinates point only. It is not exactly doing any magical things to show the line around our hands. It is basically it is trying to detect the xy coordinates points in our hands. Next comes after drawing a rectangle, it tries to identify the landmark points. After identifying the landmark, right, it will try to process, I mean, create a process, I mean, pre-process landmark means what I said to you before is using any new symbol, we can able to make the model, another model to train what is the symbol, right? Okay, for that it will create a floating values. For an example, this points, each and every point will be will be normalized actually. If we directly store this 540, 88 or 719 directly, right, then it will be a high value compute, so that it takes more resources or more GPUs to compute the process and train. If we standardize this that will become between, the values will be between 0 to 1. If we want to see that, right, the values will be like this each and everything will be a single point, but it will be converted into this will be this is converted from this actual point which is generated. Okay, right? If you have any questions, please post it in chat. After that there is a pre-point history. This pre-point history is something which we have already stored and trained the model, so that it will be easily able to this will be able to easily identify the name of the this will be able to identify the name of the symbol what we are showing. This is called OK. This hand symbol is called OK, means it is basically getting the data from already previously stored history. That is happening over here. After that comes the what is the next part. Once these are all done, right, this will be passed to a key point classifier. This exact points, all the points will be passed to a key point classifier, where we import a model over here. Currently we are using key point classifier.tflight model, where the key points like this, right, which I showed you over here, right. these points will be passed to the model as an input. Then the model will be giving us a multi-class classification as an output. If these points are all passed in, it will give us give a value of 4, because maybe we can consider this 4 as an index value. If we check what is the 4 in the key point classifier label, then the 4 will be 0, 1, 2, 3, 4. The fifth value will be the 4. So it is the p symbol the person is showing. That will be the output from the model. So it is able to identify from that manner. The last in the main classes, the last thing occupies the drawing, which I mean drawing means what I'm saying is giving the FPS count, or finger gesture is in stop, or drawing the bounding box, writing the name over here. These are all the things are taken care by the computer vision. OpenCV. It is not taken by computer vision. It is taken care by OpenCV to give what should be printed or what should be shown in the display screen, right? Those are taken by the OpenCV. We can see here, right? We cv.rectangle draw this thing. That is all happening this app.py file. This is the overall app.py overview. And here, as I already mentioned, we can custom train our symbols, right? How can we custom train our symbols? We can see now. First of all, there is an option to start the training. Those keys are accepted in the main.py file itself, but to show you demo, right? We can see the live feed. If we try to, actually this is showing p symbol because it is morely related to the p sign. If we try to just add a little finger to this, right? First of all, we need to start start this process by clicking the letter key in the K in the keyboard. Once the letter K is clicked, we can see here, right? Mode is equal to login key point. I think it is in the white screen. Maybe you can't see, but now you can see mode logging key point. Once this is started, then we need to press any of our numerical keys like 1 to 0 we have now. Once that is done, right, I'm just starting like for this symbol, I'm just clicking number 8, for example. I'm just clicking. We can see here what is the number I'm just clicking over here. It basically does store all the key points of each and every value, right? This will be stored as a 2-value matrix in the matrix, right? This will be normalized and stored in the CSV file. So for that, we are just clicking and we are showing a different, we are basically getting the data point in the live form. By showing this, just okay. I think this will be somewhat okay to start. I think so. As of now, I have just showed the symbol and stored the key points. To verify this, we can see it in the key point CSV file. As I clicked it on 8, right? Here we can see the key point of 8 and the value stored in the stored as normalized form. This is basically we train the machine learning model in using a CSV file, right? Same way we are going to train a ANN model over here. It is basically ANN is a artificial neural network model, which is a deep learning model. We are going to train over here. We have the data points, all the data points over here. Once this is done, right, we should add the what is the label name of this. We can add the name by what can we add now? Okay, we can add like test data. We can just add for a test data. We can add as the name. For each and every hand, we can train different symbols. Once this left, now we have shown the left hand, so it will be able to easily identify the left hand, and we can also see that which hand we are showing, it could be easily able to identify left hand or right hand. So each and every hand can have its own symbols, its own definition. Once this is done, the mode logging key point mode is over. You can just click N to stop this. Once that is done, we have now set up the key point classifier label. Also, we have set up. We have the data points in the keypoint.csv file. Once this is completed, we are going to open the key point classification notebook. Basically, this notebook shows us how to train a new model or an improvised model from the old model what we are using now, so that it should not forget the old data also. Basically, we are importing the keypoint .csv file which we should store now, and this is the model what we are taking for improvement, and this is the model what we are going to train and give an output as a TF Lite model. So this TF Lite model can be used in mobile phones also, or any desktop, or even now I'm just currently running this in CPU mode. So even though if we are running in CPU, there is no much lag over here. We can easily, there is no, we can see there is no lag here. Even if we try to run this in GPU, right, still it will be more efficient and more powerful when it comes to GPU. So initially we need to specify what is the number of classes we are using. As of now, I had around 8 classes. Now I am just added another class 9. After that, we are loading the data over here. Then we will be splitting it. Actually, I'll be start running this also meanwhile. Once we splitted the data points into test data, train data, right, then we are ready from the data set preparation part. Now to train the new symbol, all the data set part now it is over. Next, we are building a custom model where first of all we are getting the values as 21 as an input over here. That is the input value to the model. So 21 key points can be given as an input over here. Then we are adding that is the first layer, into the input layer in the deep learning model. Then then comes the second layer where we are dropping out 20% of the input layer. It is dropping out means to this dropping out feature is actually introduced to not overfit the model. We have only 21 input points, and also the data point what we record now, right, that is somewhat very less comparatively. So it should not overfit. Overfitting means basically it will only if it sees any data related to only the training data, it could able to answer. It cannot generalize itself. Then we are adding a hidden layer where we are adding 20 neurons, and the activation function is ReLU over here. ReLU activation function is used to calculate the weightage of each and every neuron. ReLU means after putting the value inside the ReLU, if it is above 0, then actual value will be stored. If it is below 0 or any minus value comes out of the function, then it will store it as 0. That is the ReLU activation function over here. If you are learning deep learning things, like this in depth, you must you must be able to understand the in-depth part, like how to form neural network, and how should you give the activation function for each and every layer. What should each and every activation function do? Everything you should be able to understand. Those are the main thing. Then comes we are again giving a dropout layer with the 40%. Once after getting completing the 40% rate, we are then adding the 10 hidden neurons over there, and we are also giving out output class. Output class is the number of classes what we have specified over here, so that our hand samples will be within the classes what we have already specified. We are using softmax function. Softmax function is basically used for multi-class classification over here. If we want to know what is ReLU, what is softmax, that is a big topic. We can understand. If you are interested, you can just browse it in the Chrome. If we run this, the model is ready. If we want to see the model summary, right, this is the model summary. We can see the parameters over here. Nowadays we are hearing for each and every LLM it is 3 billion parameter, 8 billion parameter, even like GPT-4s are nearly 2 trillion parameters. Now currently we have totally 1169 parameters only we are having. The model size will be around 4.57 KB. then think of how much big will be the GPT-4, and one around 2 trillion tokens, I mean 2 trillion parameters means, think of the model size over there. And also you need to think of how much layers and how much hidden neurons they should be adding in the model file. So we can see how is the parameters calculated over here, right? Once we are passing that into 21 into 2, that becomes a 48 input neuron, which will be passed to the dropout layer. We can see the dropout layer starts. Once we are passing that to dropout layer, right, next will be the hidden neuron, which will be accepting that. So if we are interconnecting all the neurons, right, then we will get around 860 parameters over there. So after that, once we got the 860 parameters, that will be staying in the first hidden neuron level. Then we are adding the dropout layer, so that doesn't make any improvements over there. Then comes the we are adding up 20 hidden neurons in the as a second layer, and after that we are adding a 10 hidden neurons over here. We can see as a dense layer. These are all hidden neurons over there. If we are just multiplying it, right, we could see around 20 into 10 will be around 200. But each and every neuron will have its own weight, and after each and every input, right, we will be adding a bias over there. So if we go into each and every terms like what is bias, I think that will take a lot of time. If you want just to explore in Google or something, so we need to add bias over there. So it comes around 20 into 10, 200, plus the bias values will be 10, because each and every neuron will having the last one bias. So it will be coming around 210. After that, also if we just multiply this two, right, 10 into 9 will be 90, and the last 9 values will be like the bias value over here. So if we totally calculate the parameters in the right side column, right, that will be around 1116. And this is the total parameters or the weights which will be used to decide what is the symbol shown in the camera feed. Okay, right. Then this is used in the to load the data, I mean load the model which we already have. We don't want to train from scratch, but this is not this is not compulsory over here. But if we want to if we are using in a large scope and we are training more symbols, right, then this will be more useful. Once we train a model and use it, if we want to update that model, right, then this will be useful, because the old model weights we will be updating, uploading, then we will be updating this next only, adding only one symbol next. Then this is used for early stopping. If we are just training 100 epochs over here, but after 500 epochs or 200 epochs, the results keep on coming out in a more similar way, right? Then we can stop the training, because it will be we can minimize the GPU usage or something, more related on GPU aspect I'm speaking over here. And when it comes to model compile also, right, I will run this code. Model compile, we are using actually Adam optimizer, which will be deciding is that model reached its highest accuracy level, or like that optimizer are used to train. And when it comes to calculating loss, right, loss, we are already we said it is a multi-class classification, but here we are using sparse categorical cross entropy. This will be acting on the final layer part, so that it will be easily used to identify what is the neurons coming to say, which is the class it is showing. That part it is used over here, and metrics are all used to display it over here actually. Okay, let's start the 1000 epochs of training, and we have the batch size of 128. We have passed the X train and Y train as an input over here, and validation data is added over here, like X test data is added to validation. These two things, the old model files and the early stopping features are given as callbacks over here. Once if we start, right, I think this will happen very pretty quick for you also, I guess. Mostly I am also running this in CPU only. Early stopping has been activated over here because last 20 accuracy will be more, I mean loss will be more similar or very slow in process, so it will early stopping has activated in 170 third epoch itself. After that we will be evaluating the model using the test data. Finally we will be, I mean we are passing around 11 points over 11 steps over there. The loss and accuracy of the model is given here. We can see we got the accuracy around 95 percentage here itself. Then the next step is, once we have from initially we have using the camera, we have prepared the data. After that we have loaded the old model. After I mean splitting the data set into test strain split, we passed the data to the model and trained it. Especially we have created a custom model over here. If you are using, I mean if you are adding n number of symbols, right, like 100 symbols you are adding, then you need to add some more hidden layers, or some more model size should be somewhat bigger. 1169 parameters will not be enough to store all the 100 different symbols. We need to consider on that point also. After this we are saving the model, and we are actually predicting the passing the actual input from the test data. As I already said, right, it will be standardized, and this value will be passed to the model, and the output is 8th class. So 8th class means now only we have just trained the model, right? Maybe it is the 8th class will be the test data we provided, right? That is the main thing. So once this is trained using the test data, we are just going to create the confusion matrix. Confusion matrix is nothing but if we are expecting the 0th class should be printed, right, then how many actual 0 classes printed is 395. So it is predicting more accurately. If we are expecting 0th class and it is predicting as first class, right, like that there are 5 predictions are over there, so only we are getting accuracy around 95%. Else we will be getting, if there is all the values over the here, right, if it is 0, then it will be 100. The accuracy will be 100. See, if we see here, right, the second class mostly it identifies as second class, but also first class. So we need to improve the data of the second class, like this, using the confusion matrix itself. In what all area we need to improve the data set and all, we can easily identify. The last class is just now we added. We have given the data points around only 60 or 60 70 nearly. But when we compare to the first class itself, it is somewhat lesser. Let's try how it predicts. After that, we are just converting the model to TF Lite and saving. Once that is done, we are just storing and quantization of the model. These are all deep learning steps, but nowadays we can hear the word quantization or model saving, that and all in LLMs also, because LLMs also end of the day running inside is deep learning part is fully inside the LLM. Inference test also we can run over here. Like we will be passing the exact data, but this is nothing more different than checking it over here after the model. Model training part. We have checked the inference test here also. I have just added the notebook for separate to be getting separate details. Once this is done, right, we can also see this. This is the new model what we have trained now. Once this is done, we can just stop this. So stop this what is running, and let's start a new session. Okay, new session is started. I think this detects as open. Okay, now as we already said, right, the fold adding in p symbol. Now we need to update the data point for p symbol, I think so. Because once this thumb finger is added and the p symbol is now getting merged, right, we can see that test data is added over here. Let's try out for the right hand. Right hand, I already said, right, here in left hand we have trained it out, so it is saying test data over here. But when it comes to right hand, it is still saying piece symbol. So each and every hand we can train out different symbols over there. So that's it on this training part. Maybe I think I will share you the repository link for this also. I have this code is actually this code is open source now, and I just shared you. If you want to access all the code which I have shown now, which I have explained you, I have just shared in the GitHub so that you can use. One second. How far does the camera quality impact the gesture detection? Maybe for the first question, it is true that the camera quality depends, but nowadays the model which I have used for detecting this hands first, right? That is that I have used a media pipe model, which is already done by Google, which is already a state of the art model for detecting the hands. Even though we can see it over here, right? Even though if I am taking the hands way back also, it will be able to detect more accurately. So I think camera quality depends, but still the model will be able to perform. Are there any basic benchmark for the camera quality or benefits is going be within Supreme? I think there is no benchmarks for camera quality. Before buying the camera itself, we can see what is the pixel value between uh, a pixel value of the camera's input, right? 1080 or 4K camera or 2K camera. If the K of the camera increases, the price also increases, the quality also increases. Like that, we can compare over there and buy it over there. So can computer vision can be used on-screen things like, for example, while playing game, can it scan the character or enemy, or it can work only using cameras? I think as of now, actually, I have explored this use case. This will be a very, very interesting use case. Uh, but that cannot be done. What we assume, right, in the game itself, we can identify what is the pose of a person or an enemy over there and try to detect, right? That we cannot do. Only using camera we can do. If we are actually having a demo game which is developed by us, right, and we can customize the characters, then we can add all these functions. But in an external third party game, we can't do this. If we are just showing the mobile screen or laptop screen, which is where we are playing the game, right, we can just place a camera over there and detect the pose or estimate the pose. I think this is the answer for this. And how do we combine gestures to form a representation? A lame example: OK gesture on the left hand and OK gesture on the right hand together represent something like double OK. Okay, this is a very interesting question. As of now, this is actually detecting each and everything as a uh, individual frames. I think these two things now we can see as a data points, right? Uh, this is both are now exactly separate. But when it comes to capturing, right, after clicking K over here, and we just start to capture, then I think these both points will be separately stored with the data point what we are giving. If we are pressing then 8 or 9, right, then that will be stored in the separate form only. I think double OK uh, exactly can't be done like what you have mentioned here, but we can easily make use of the both the hands to predict, store it as in, store in the data values, in the CSV files. Last thing, Gautam, can we use pre-trained model and fine tune it to classify more gestures? Maybe uh, actually we are currently doing that process only. Initially we are using 1 second. Sorry. Initially we are using key point classifier HDFI file, HDFI model. Then we are it is not exactly fine tuning, but we are observing the weights from that model and updating on that model. Updating on that weights and storing it as a new model, which is kind of fine tuning part. Then comes, and we need to grayscale the data set, or can we give It does. It does such for training. Maybe I can't understand the exact question, but still, from my understanding, I'm saying you can initially for this use case we can give RGB image as an input itself. Now we can see, but when we are speaking about larger view on computer vision, right? Uh, First of all, we need to clearly define the use case. Then we need to plan about that. So that do we really need a really need a grayscale image or a colored image? If we want to detect the object and still want to identify some colors, right? Then okay, if you are building a use case for a cloth store, as soon as a person enters the a shop, you want to detect the image, detect the person. As you detect the person, you can also identify color of the shirt the person wearing. It is very easy. We can draw the bounding box, and after inside the bounding box, just move 100 pixels over there, and you can just identify what is the color of the single pixel. So in that use case and all, we can easily we need a RGB as an input. Some use cases we don't even need RGB, only grayscale is enough, I think so. So this works well in computer with decent FPS, but in Raspberry Pi the SPS is pretty low. That is true because in computers the number of cores present here, or the number of cores which is processing, number of thread inside each and every core is totally different than a Raspberry Pi. uh, and if your laptop has some GPUs, right? Then it is still more still more easy for computers. But if you are trying to run a model in GPU, then that gives FPS around 20 or 30, right? If you try to run it in Raspberry Pi, that will be giving around 10 15 around that FPS only, because it has very low processing power. There is one method is still more, you can make the model still more light. I think TensorFlow supports Raspberry Pi optimized model, I think so. I'm not sure with the name of that. Even TF Lite is very good for deploying it in edge devices or edge computing level. Uh, Now today morning I was seeing Raspberry Pi also have a AI module which will be able to process 13,000 trillion operations per second. 13 trillion operation per second. So if you are trying to use that, adding that module in a Raspberry Pi for for a use case, that could able to do well, I think so. What are the main features extracted from training? How can we answer this? What are the main features extracted from the training image by the model? I'm not sure what to answer, because if we are trying to train a classification model for a cat or dog, we can't exactly interpret what's happening inside the model. Where is the exact part? What are basically the model will try to understand how will be a dog be. For that, it must identify what is the shape of the dog, what is the average height of the dog, what is the how is the ears of the dog present. So everything will be understand in the numbers. But how can we say that this is a exact features extracted from the images? I think that is that much interpretability in deep learning models have not reached, I think so. Yes, I think is this questions over? I think Siddharth.
Okay. Anybody else has any questions?
Yes, yes,
Yeah,
Manoj.
I have a slightly longer question, so I'll ask you
Yeah,
definitely
go ahead.
to audio. The thing is, so in the example that you showed us, there was a sequence of the landmarks, right? So basically, the fingers were connected, right?
Mm-hmm.
So is it a requirement, or is it just like basically what I mean is, let's take the features of a face, right? Let Can we point the landmarks for the lips separately and then the eyes separately and then combine them to form an expression? Is that
Yes, that can also be done. Actually, this method, right, this pose itself, training method actually. For any object or any something slightly moving object, you can train the model according for this pose itself. But forming the data set for this pose is slightly harder, because most of the use cases come around a human body. So there are already pre-trained models are available in open source community itself to use it in this post, but it can be used for separately for lips or separately for eyes for expression level also we can do. Yes.
Yeah, thanks for that.
Thank you.
Any other questions?